All right, I want to thank everybody for coming to our 2023 ACP-HLB grower meeting. The ACP-HLB task force is a subcommittee of the Farm Bureau of Ventura County that was established about 10 years ago in order to have coordination and collaboration in the county to combat the threat of HLB and ACP here in Ventura County. Over the 10 years, the mission has had a variety of different tasks that they do and very focused on education and outreach to growers. So this meeting is one of the big events that we do throughout the year, and we want to thank you all for coming here and being a part of our mission to combat ACP and HLB in the county. For today, just on a housekeeping note, the bathrooms are through that door on the left, and then you hang a right and there's bathrooms there. If you need 4 hours of DPR credits, those are only available for in-person attendees, and the sign-up sheet is at the front, and I'll distribute those certificates at the end of the meeting. Today, we're going to have variety of speakers, starting with Neil McRoberts from the Western Plant Diagnostic Network, UCIPM statewide program, and UCDavis plant pathology, and followed by citrus pest and disease prevention program representatives Victoria Hornbaker and Keith Okasaki. Those are going to be our first two presentations. We've allotted a lot of time so that we can have grower questions. So if you have a question here in the audience, I'll have a microphone after the presentation to spread around. If you're an online listener, then you can put your question into the chat, or at the appropriate time, raise your hand so that we can make your voice audible to the rest of us. So with that, I'm going to welcome Neil McRoberts to the floor for our first presentation. Thank you, Neil.
Thanks, Maureen. Good afternoon, everybody. It's lovely to be back in Ventura again. Ventura County, I guess. We're not actually in Ventura itself right now. And good afternoon to everybody online too. Welcome. So I'm going to kick off proceedings with this talk about the results that we announced back just before Christmas in November. This is an ongoing project that's been running for a couple of years, in addition to collecting psyllids in Ventura. We're also collecting them from properties in Riverside and then down in San Diego. And I'm going to tell you a little bit about the results that we've been seeing, and I'm going to try and put those results into context for you so that you can gauge how anxious or not you feel you should be on the basis of what we're seeing. So that's where we're heading, okay? And in addition to what Maureen said about there being lots of time for this, please feel free to, if you're in the room, raise your hand as I go along. Double check that you heard the information, that you understand what I said. If I say something that you don't follow, then give me the chance to make sure you do understand it before we move on to the end, or it may not come up. Okay, so I'm going to kick off by just a quick reminder that there is a voluntary response plan for growers in place that was written 2 or 3 years ago. The grower liaisons will be able to walk you through this in a lot of detail, but the main points are that there are things that the industry can be doing already in thinking about how to manage the vector, the psyllid, and then also hopefully we never need it, but manage trees if we're in the situation of having HLB. And really, you're already doing one of the most important things by being at this meeting, which is participate in the meetings, get informed, stay informed, keep up to date with the advice that comes from UC, that comes from other sources of information too. If you want to be active in helping with the situation and keeping your own citrus healthy, then you could consider doing things like scout for the nymphs of the vector. You can be trained to do that. We've had several training events already. We can organize more. Participate in efforts to control the vector population. I know prices are low at the moment and there isn't a lot of money around for doing things, but as I'll emphasize at the end, doing something is better than doing nothing, even if you don't either have the money or the technology to participate in sort of full-on conventional spraying, or if that's not what you want to do to manage your citrus. There's a range of things that everybody could do a little bit. And then there are additional options, things that you can try, like again, it's resource intensive, but work from Texas shows that putting up barriers along the sides of blocks can be particularly effective for excluding psyllids if there's a direction that they come from that's where they tend to come in. There are early detection methods. There's work going on. We've got Doug with us this afternoon. There's work going on to try and improve the efficacy of those. There's a bunch of other things too. The bactericides probably not relevant to California at the moment, and Florida experience has been touch and go with those. Okay, there is a lot of information on this slide, and I'm going to walk you through it piece by piece, and I want to kind of emphasize a story that comes out of looking at all of these things. The charts with the gray background, so there's two on the left-hand side and one over on the right, those are available online at the DATOC website, which is just datoc.us. And we keep a summary of data from the statewide program on that website for public viewing all the time. So if you want to know what state the epidemic's in, how many trees have been found, I mean, there are lots of places where that information is aggregated, but that website gives you a kind of a dashboard where you can find things easily. Okay, so the two gray panels I got over on the left-hand side of the screen show the level of the bacterium in the trees that have been detected positive in Southern California. That's the top gray slide with the dense spots. And the one below shows the bacterium level in the psyllids that have been caught that have had detectable levels of the bacterium in it from the statewide program, okay? And you can see in both of those plots that the red spot, which shows the average for the psyllids, and the green spot in the slide above, which shows the average for the trees, they kind of wiggle up and down, but they're not trending upwards, okay, which is a really great sign. Okay, we're really happy to see that. There's no kind of strong evidence that the bacterium level in the positives is going up. So that's great. The other thing that's really good is if you look at the bottom panel with the one for the psyllids, the scale on the left-hand side goes up to a maximum of around 6 at the top. Okay, it's a log scale, but it goes up to around 6 at the top. And we know from fairly detailed experiments that have been done in Florida in colonies at the Fort Pierce lab that unless the bacterium level is up around that kind of 6 level, the psyllids are not actually very good at transmitting the bacterium to the tree if they're not kind of really loaded up with the bacterium at that level. And you can see in what we're picking up in the environment in LA that most of the psyllids are not that infected. Okay, they're not, the bacterium hasn't built up in the psyllid population to a high level yet. So we want to keep the level in the psyllids down around where it is at the moment. Okay, now how does it increase? Like if we sampled psyllids in Florida, they would all be full of bacterium, and the points would all be way up at the top of the graph. How do we stop that from happening? You kill the psyllids and you get rid of the positive trees when you find them. And by doing that, you don't allow the feedback loop. It's like a positive feedback loop when you put your microphone too close to your loudspeaker, right? That's what allows the bacterium to multiply and build up. Okay, so by killing the psyllids and taking out the infected trees, we're stopping the bacterium from being able to multiply all the time and the concentration goes up. The other thing that helps us here is the climate. Okay, so hard work on your part, on our part, and pure dumb luck that we're in California. Mother Nature lends us a big hand. I'm going to talk a little bit more about that in a little while, but basically we don't have very many good psyllid days in California, not compared with Sao Paulo in Brazil or Indian River in Florida. Okay, we get enough that I don't like it, enough good psyllid days that I don't like it, but we're doing pretty well. So let's keep working with nature to stay on top of the problem. I want to illustrate one thing though by looking at the rest of the slide here. So the main center panel of this slide shows the proportion of traps out in the environment that had detectable psyllids on them over a period of time from 2015 through to about 2020. We haven't updated this data set recently. And the different seasons of the year are picked out on those graphs in different colors. Okay, and you can see Ventura is the bottom of the bottom one all on its own down there. Okay, and you can see early in Ventura that way back in 2015-16, the proportion of traps that were catching psyllids out in the environment was below 25%. But then the number ticked up between 2015 and 16. You can see there's a first little hump on the slide, and then between 16 and 17, it really shot up over the summer, and then you can see the winter, it dropped down again, and then it shoots back up, and then it shoots down again. So you can see the seasonal effect on the psyllid population in that bottom little graph with the colored points on it. Okay. And you can see that the seasonal effect is actually much stronger here in Ventura than it is in Imperial or Riverside or San Diego. Okay, it goes up and down in those places too, but the seasonal periodicity, the ups and downs, are more pronounced here in Ventura. Okay, a bit further north, so winters are a bit colder. The change from winter to summer is more abrupt, so you get this stronger oscillations going up and down. The long blue graph at the bottom right-hand corner, okay, is the same period of time, but what's shown in that graph is the numbers of psyllids caught each month total in the south end of the San Joaquin Valley in Kern County. Okay, so there aren't very many. They're mostly hitchhikers, we think, that come in one way or another. But what you can see there is that there's a big, nothing much happens for the first few years from 2013 or 14. And then in 2015, that blue line jags up for the first time. And then it's pretty high all year during 2016. And that was the year that Bakersfield had a big outbreak. 2017, there was a big uptick towards the end of the year, and then it kind of went quiet again. And then 2019 was 2020 was a bad year. 21 was kind of quiet, and 22 has been really noisy again. And those peaks that you see there in that graph for Kern County correspond to where we're seeing increases in the other graphs too. Okay, it's hard for your eye to match it up, but I spend a lot of time looking at these things, going cross-eyed, playing with the numbers on the computer, and there's a correlation, right, between what we catch in Kern County and what's happening elsewhere in the state, which tells us that there's things that happen at a statewide level, there's good years and bad years for psyllids, okay? And that has two lessons in it, right? A couple of good years in a row is not a message that the psyllid is going away, or that we can afford to be, that we can afford to take our foot off the gas. Equally, a bad year doesn't mean that it's going to be bad permanently, okay? There seems to be a kind of periodicity, a cycling up and down in the psyllid population. And that's what you would expect when an insect invades a new area for the first time. It takes a while for the ecology to readjust, but we're kind of getting into something that looks a bit like we understand what psyllid population dynamics are going to look like in California. And we're going to see these cycles up and down. And then the last thing, the green bars are just showing you the number of infected trees that have been detected each year in the program in Southern California. So there's a slight uptick recently, but it's not at this point possible to say if that's because there are more infected trees out there now, because it could be that what's happening is the survey program is finding hotspots that have been there for a while. And so every so often you just get a year in the survey program where you find more infected trees because you find a patch in the city where there's a lot of infected trees from things that happened historically. So yes, there's an increase, but it's not clear at the moment if that's because the disease is spreading more down there, or if the survey program's just hit some hotspots and is in the process of clearing them out. Okay. So all of the slides that I'm going to use today will be available if you want them. So I know there's a lot on there and we went through it relatively quickly, but if you have any questions or want me to go back over any of that, I'm happy to do that. Okay, why are we seeing these kinds of patterns? And here's what I was talking about when I said California is not really good for psyllids. So the top left-hand panel here, okay, shows the kind of suitability on a day of the year basis for a whole load of different places in the world where citrus is grown. So it starts on January the 1st, and then there are 365 little slices that make up each of those colored strips. And each one is the day of the year. And what we did was look through the literature and all the studies that tell us about the effect of temperature and moisture on psyllid growth. And we calculated an index for each day of the year for each location based on the weather data to say, is this a day that would be too cold for psyllids, coolish for psyllids, really great for psyllids, and then too hot and then likely to kill them because it's way too hot for them. So if it's blue, it's a day that's probably on the cold side if you're a psyllid, and if it's black, it's a day that's so hot that it might kill you. If it's dark red, it's so hot that you're going to not be very effective at being a psyllid, and so on. Okay, so psyllids like it when it's kind of in the yellow and orange area. Okay, and the top few strips are from Brazil. Okay, so you can see the place that we've looked at so far that has almost no days that aren't great if you're a psyllid is in Brazil. Okay, and then as we come down the graph, we get more, we go through some Florida locations and then into California. Okay, and Ventura's in the middle there somewhere. What happens here is that we have a long winter that's too cold if you're a psyllid, so they're not very active. It probably doesn't kill very many of them directly, but it certainly stops them from moving around much, and then other things can eat them more easily. So it goes from being too cold to being on the hot side really quickly, right? It's a feature of a Mediterranean climate that you come out of relatively cold, dry winters into hot, dry summers without much spring, and then again at the other end of the summer without much fall. Okay, so one of the reasons why psyllids don't particularly like California is that they don't get 3 or 4 months in a row when it's just great for being a psyllid, right? And it takes about 3 to 4 weeks in summer temperatures here for a psyllid to complete its life cycle. Okay. And in order to spread the disease, they have to complete a life cycle. So lots of different things need to line up to spread the disease here. It has to be warm, but not too hot and not too cold. And there aren't too many days when that happens. And then the psyllids need flush. Okay. And the gray panel shows data that were collected by the CDFA biocontrol release team. And so thanks to Dr. Morgan for letting us show these data. So they go out across Southern California and release the biocontrol parasitoid. And while they're out there doing that, they look at the trees to see whether they're flushing or not. So they collect that data because they can while they're out there. So these are for dooryard trees. You can see what percentage of the trees that they looked at were in flush in different years over the course of the year. 2015, when they started, was a really funny year. It started really high and then it kind of dropped off. And there was way more flush around in 2015 than any of the other years, apparently. That's that black line that kind of slopes down above all the others. But then you can see in almost all the other years that they've been out and done this, there's a big peak of flush in the spring, and then it drops off. And then depending on how moist it is, how long, whether there's been spring rains and things like that, you have some years where there's almost no flush at all through the summer, and then other years where there's, even in these dooryard trees, there's 20–25% of the trees at any point in time might be flushing, but not more than that, right? So once the spring's passed, at least in trees outside of commercial citrus, it's not like psyllids are finding flush everywhere to grow on. Okay, so now we can think, well, okay, how do we line things up to suit us so that we make sure that there's as little flush available during the periods when it's good for psyllids. And here in Ventura, it's generally too cold for them in the spring, right? We don't see big population explosions in the spring. It's only at the end of the summer when they've had enough warmth through the summer that you tend to see a really big uptick in the psyllid population. So I've taken the graph that we were looking at before and blown it up, the colored one that shows the different seasons on the top right, just so you can see. And again, this is the percentage of traps out in the wild that have got psyllids on them. And so you can see the seasons picked out. The red is summer, the gray is spring, the yellow is winter, and the blue is fall. Okay, I think maybe blue's winter actually. But you can see that they go in sequence, right? How do we know? Why are we confident that this is that we understand how the psyllid dynamics are being driven? The graph in the bottom right-hand corner is a development model that we built that uses data from experiments that shows how much heat it needs for the different life stages of a psyllid to develop from one stage to the next, to the next, to the next, and then for the females to lay eggs. And so each of the little lines on the bottom graph are the different life stages. And the model is being run in that case from a weather station in Southern California. And you can see that the pattern in the model matches the 2015 and 2016-17. So that kind of double peak. There's 2 years of psyllid development in the model output. And you can see that idea of the increase towards the end of the year, and then it drops off when it's too cold, and then it increases again in the next year. So that pattern in the model matches what we're seeing in the trap data, okay? So we know pretty confident that we understand psyllid development much better than we did a couple of years ago. And so this is what happens, right? And this is what happens here in Ventura. The population gets knocked back over the winter when it's cold, and then it builds up again, okay? But it can only build up when the temperature aligns with the availability of flush, okay? So we can start to think about when is it most important to protect your trees or to be out there trying to bear down on the psyllid population, it's during those periods when it's warm and the trees are flushing. Okay, those are the really high risk periods. So it's not like we have to think about it necessarily as a sort of continuous 12 months of the year, everything at fever pitch activity. Okay, we understand there's a bit of nuance in it now, and maybe that will help to home in on the target. So to understand a bit better what risk those psyllids represent, how much of the bacterium are they carrying around with them, we established this project a couple of years ago. It started with me and Monique Rivera and Judy Brown in Arizona. And when Monique left to go to Cornell, Frank Byrne took over management of the project. So there are five sites here in Ventura, 5 in San Bernardino, 5 in San Diego. They're visited on a regular basis. And at each visit, the field team takes a suction sampler, a DVAC sampler, and they suck all the adults they can find off of 10 trees on each side of the orchard. And then if the trees are flushing and they find any flush with nymphs on, they clip the flush, and all of the insect samples go to Riverside. They're sorted. Stuff that isn't psyllids gets counted as well because they're entomologists and they want to know that stuff, and then they throw that away. And all the psyllids go over to Tucson, where Judy Brown runs them in the lab to find out whether they've got CLAS in them. So we started to get results last year, and after Judy altered the protocol a little bit in the lab to optimize it a little bit better, we started to get a clear picture of how much CLAS there is in those psyllids. Okay, so a couple of things to say about all of this. This is a research project, it's got nothing to do with the regulatory program, okay? It's a completely separate exercise from the statewide program. So even if you'd think something might happen on the basis of these results, it's a good thing that it doesn't, right? And all that we're bound to do is notify CDFA if we find things, so that they have the chance, if the growers agree, to follow up to do regulatory sampling. Okay, so if those of you may be thinking, why hasn't something happened on the basis of us knowing some of this stuff for a while, it's because this is a research project, not a regulatory exercise. Okay, but we work very closely with Victoria's team to make sure that everybody is on the same page. So here's some results. Between January the 1st last year and the middle of July last year, these are the numbers of adults and nymphs we found in the 3 different areas. Okay, so this is what was sucked off of the trees or clipped on flush. And you can see Ventura's not the highest in either of those categories. Okay, San Diego had by far and away the largest adult populations, and also we found more nymphs down there than here in Ventura, with Riverside somewhere in between. Okay, so no surprise, you know there are psyllids in commercial citrus here. Now, this isn't telling you anything you don't already know. Okay, but that's just to kind of give you an idea of what we see in a 6-month period. Okay, so here are just the Ventura data for the 5 sites, and these are the total numbers of adults. I'm not going to show any data for nymphs. We haven't processed the nymph data in the lab yet. So here are the 5 sites, and the scale on the y-axis is not consistent between these charts. So take a look at the number at the top on the left-hand side before you kind of decide, you know, whether you think that's a lot or not, because it changes a lot between those different locations. So for example, site number 3, which is the one at the right-hand end of the first row, is a conventional citrus orchard. And you can see there's a big peak at the end of 2021, and there's a big peak in the spring in 2022. And then it's continued to be relatively high it continued to be relatively high all year in 2022. And the scale at the top there says 300, okay? Compare that with, say, the site next door, which is also conventional. I think the scale at the top of that says 60, right? 50, okay? So it's a much less heavily infested site 2 than site 3, okay? But you can see there's some correspondence between where the peaks are, even though they're at a much lower level, okay? And then there's 2 organic sites, site 1 and site 4. And site 4 actually, the data consists of 2 completely separate sets, because there was an orchard, and then we switched to using a new orchard after the first few months, because the old one, I think, got taken out. Okay, but you can see, for example, that the 2 organic sites, the scales are lower than at that very highly infested conventional site. So it isn't necessarily true that organic sites have a higher population than conventional. It's not always the case. And then site 5, again, another conventional site, we saw a huge increase there just at the end of last year, when across the whole state, we were seeing psyllid numbers go up. So here's what 2 years worth of catching psyllids looks like at 5 different locations across the county. And the team are going to be continuing to work through until July. There's been a little bit of uncertainty about who was around and who would be staying. A couple of the technicians are leaving to go back to graduate school, but Timo is going to be continuing to work through until July on his own, still collecting psyllids. So he won't be able to come out as often, but he's going to be there. Yeah. Okay. Yeah.
We have a couple audience questions. So first, Jane.
2 questions. One is, are these all lemons, or they're lemons and oranges? And then question number 2 is, with the organic, are they like out in Ojai where it gets 115? Or, what's the locations basically? So that, because, like Fillmore or Piru would get real hot and coastal doesn't.
Yeah. So site 1 is an organic orchard in Ojai. The others that's the only Ojai location. The others are kind of spread in the Santa Paula area, or down onto the coastal plain around this area. I don't know exactly where the other ones are off the top of my head. I know that site 1 is an organic site in Ojai. And I think there's either 3 lemons and 2 oranges, or 4 lemons and 1 orange. I can't remember that off the top of my head either, but I'll get you that information and let everybody know. Okay. Okay, so there's psyllids out there, no big surprise. How much sea lice, how much bacterium have they got in them? In the 2021 samples, those are the numbers of samples that the Tucson lab identified as having detectable sea lice in them, okay? So in Ventura, there were 15 samples in the 2021 data and 7 in the 2022 data, where Judy was able to pick out a signal from the PCR that said there's some sea lice in there, okay? Now, I'm very carefully avoiding using the word positive, because that word has a special meaning when it comes to regulatory decision making. So we're just saying we can find the bacterium, okay? It's detectable. And you can see what I've done with those little graphs with the spots on them on the right-hand side is actually take those individual samples and plot out what the PCR value actually was, and broken them into 2 groups. So the red group is PCR results where there's a strong signal, okay? And then the blue ones are samples where there's a detectable signal, but it's not strong, okay? Basically, the higher up you go, the PCR kind of works in reverse, and the higher up you go, the weaker the signal is, okay? Because what that number is the number of times the machine has to go around to multiply the bacterium up to a level where the detector can pick it up. And obviously, the more times the machine has to cycle, then the lower the concentration you started with, and it takes longer to build it up to a level where it's detectable. So in those 22 samples, there was a mixture of some that were really strong and some that were less strong. And I've brought back that gray slide that we saw earlier, right at the beginning, that shows the concentration of the bacterium in the samples that are collected in the survey program, the statewide survey program. So the question is, where does the data from the Tucson lab that was collected here in Ventura, where does it lie on that same graph, right? If I was going to put that data on the right-hand graphs and do the calculation that translates it into the values on the gray graph, where would the data fall? It would fall almost exactly in the same place as the spot for the average for 2022. So you see where that red spot is for the 2022, the last kind of strip of data in that gray background graph. The data from here in Ventura fall almost exactly aligned with the average there, okay? Which is reassuring, and also tells me that the psyllids here are not in that really high worrying level, right? We're not seeing really, really hot psyllids being collected in this research project we're doing, which again, if you think back to what I said right at the beginning, it means that they're relatively inefficient at that concentration. They're not great at transferring the bacterium to the tree. I'm not saying it wouldn't happen, but it's not guaranteed to happen at that level, okay? So this is good news, okay? It's not good news that we're finding CLAS at all. I'd much rather we didn't find anything. I would love to be standing here saying 0, okay? We're not there, unfortunately, but where we seem to be is in an okay place. And again, it's not a case that things are hopeless. You know, the psyllids are not hot. They're detectable, but they're not burning up. So the transmission of the bacterium isn't going to be that successful. And we've got the climate working for us too. So these, to me anyway, this is all reasons to keep making an effort, because it's not like this has got away from us. Okay, so I'm really happy to see that. Okay, I didn't bother to put the data point on the slide because it was basically hidden by the red spot that was already there. Okay, but that's basically where they are. They're kind of bang in the middle of what we're seeing elsewhere in the state already. Okay. So this is just a reminder. I'm not going to say any more about this. Why not to give up on ACP control? Because the climate's working for us, because out in dooryards, we don't have year-round flush, so the psyllids don't even have opportunities to multiply sometimes, even when the weather's good for them. There's certainly periods of the year here in Ventura where the population gets knocked back by the cold weather. We don't get any summer kill. It's not hot enough probably to kill them in the summer. And we're getting better at understanding the dynamics, so we've got a much better idea of when they're going to be a risk, and we'll be able to set up a dashboard, a projection dashboard that will predict out when the different generations are likely to appear. Not saying that you would want to try and funnel your control efforts exactly onto those predictions, but all of this information can be used to help people make better decisions about when to use the valuable resources that are available. A couple of other things I want to just quickly say about overall effort to control psyllids. We know that Tamarixia is pretty good at finding them and killing them. And we also know that a couple of generalist predators are pretty good at reducing psyllid numbers too. And hoverfly larvae are particularly effective. Okay, so if your approach to psyllid management is kind of more holistic and less based around pesticide use, then what I would love to see happen is for Ventura County to kind of be carpeted with alyssum and other open flowered plants that hoverflies really like, the adults really like. If you could just fill up every available space with some plants like that, we'd have hoverflies in abundance, and that would have a huge impact on the psyllid population. And wouldn't it look nice? Wouldn't it be pretty for people driving through Ventura to just see alyssum everywhere? I think that would be great, you know. It's not expensive. And if people start buying it in bulk, I'm sure the price will come down, because whoever it is that grows the seed will get the idea that there's a market for it. It's not the only plant that hoverfly likes, okay? But for those of you who don't like spraying, plant open flowers that hoverflies love. Your trees will fill up with hoverfly larvae, and they're pretty aggressive psyllid eaters. And they're pretty good at defending themselves against ants too. They're big enough and aggressive enough that if ants come and try and defend the psyllids, the hoverfly larvae will have a go at killing the ants as well. So let's get some more hoverflies out there to work alongside chemical control. And there are organic pesticide options too. Okay, so summary points. This is my last slide. ACP numbers have increased again across Southern California in the last couple of years. We had a few quiet years, they're building back up again. Our intensive sampling here shows that, I see a typo there, shows that numbers vary a lot, as you saw on that slide, between locations and over time. Okay, so that you're going to see quiet periods and busy periods. The CLAS levels that we're seeing in those psyllids that we're collecting are similar to the background level that they're seeing in the statewide survey. Those concentrations are relatively low, and I don't think we're probably having massive amounts of CLAS transmission going on to trees at the moment. I'm not saying there won't be any, but just not like Florida, Brazil type levels. Okay, anything that stops the ACP from breeding continuously, anything that breaks up the breeding cycle for the ACP really has a dramatic effect on the way that the disease builds up. Okay, just think of ways to stop them from breeding. You don't even have to kill them, just don't let them breed. And then the last point really is just, you know, there's a tendency to think if it doesn't work perfectly, it's not worth doing anything. And I think that's maybe the biggest kind of problem in terms of attitude and so on that we see, right? Don't fall into the trap of thinking that something that only works partially isn't worth doing at all, right? If everybody does something that works a little bit, we get more benefit from everybody being involved. So do something if you can, rather than do nothing is really my take home. So that's my last point. I'm at the end of my talk. If anybody's got any questions, either in the room or out in the audience virtually, I'm happy to.
Yeah, we have a series of questions online, so I'll do a couple of those and then go to the audience since they've been waiting patiently. What is the plant that you recommended for hoverfly? Could you state that again clearly?
Alyssum.
Alyssum. And are hoverfly larvae more effective than Tamarixia?
Mark Hoddle's research group in Riverside, the data they've collected, they're slightly less effective when Tamarixia is at its most effective. But for Tamarixia to be at its most effective, you have to have no ants around. So I'd say hoverfly larvae are a really good second bet, and they're probably more reliable, even though the kill rate probably isn't as high. Yeah, there are other benefits to having hoverfly larvae out there. They work at night, so when you go to sleep, all your little friends are out helping you while you sleep.
We have a couple questions about the slide where you had a lot of different graphs. One of the questions or observations is the time of the ACP collection peaks doesn't seem to match the times best for ACP to multiply.
The collection peak, well, we're pretty much out there collecting every 2 to 3 weeks, so I'm not sure what that means.
And then another kind of follow on to that question, if the collection peaks and the best time to be in ACP were similar, would we be able to match our spray times based on temperatures?
Yeah, so that's let me go back to here. So that little graph in the bottom right-hand corner of the current slide, that is showing the development of ACP driven by temperature for a weather station. I think it's actually in San Diego in that case. So you can see basically, yes, if we get a good read on when the first few adults are around early in the winter, then we can start that model running from that date. And then we know how many heat units it takes to grow an ACP. So we'll be able to forecast ahead and say, okay, you're probably going to see more adults around at this point, and then this point, and then this point. And we already do that for some other pests. We do that for thrips in the Central Valley over the summer to help the tomato growers time things in that location. It's obviously more stable there in terms of weather and more reliable, so it probably worked better than here. But yes, I'm hoping we'll be able to like do a sort of ACP forecast to kind of project out when the peaks are likely to be over the summer months. But it gets messy the further out from the winter you go.
When you're collecting the adult psyllids, how much time is allocated per site?
I don't know. I'll ask Timo that and get back to you with an answer. Sandra, you don't know how long they spend, do you? No. Yeah, I'm sorry, I don't know.
For the bottom left figure, are those residential trees? And what measurements on flush information are available for commercial production trees?
That is a fantastic question. Yes, those
It
are
was an anonymous question.
anonymous. That's a great question. Yes, those are though the data in that little graph on the left at the bottom are all from dooryard trees. And this question of when are commercial trees in flush is an open question. And we're currently talking about how best to answer it. And my response would be like, do a little survey, right? If you guys know when your trees are flushing, right? If you just, and it doesn't need to be any more accurate than what day would you say, yep, we're in flush? And then when you get to the end of that, what day would you say, using your judgment, yep, we got to the end of flush? And if we had that information from, say, 100 growers across the state, then we would be able to answer that question. But believe it or not, at the moment, we don't have either a temperature-driven physiology model that says when flush should start or end, and we don't have a set of data like that. Nobody's ever collected information from the industry to say, when does flush start, when does flush end? And of course, sometimes it's just continuous, right? There's some flush all the time, but there are periods when it's more intense. And if we knew when they were, then that would be helpful. So that's like a community project for the community to do. It's like, send in your flush data, and then we'll be able to answer that question.
Specifically for sea loss in trees, do you yet have a medium for growth of the bacteria, or is the determination all done by PCR?
Yeah, it's all done by PCR with tissue sampled from the trees. There's still no reliable way of growing the bacterium in culture.
And then as we're seeing the ACP populations go up and down year by year and by season, what is the evidence of the efficacy of what we're doing, the growers?
Yeah, I wish I could give a straightforward answer to that question. We're really not 100% sure. Okay. We know in situations where nothing is done, the psyllids get worse than in situations where there is management. But it's actually really difficult to kind of unpick what the difference that the program is making and that growers are making through their efforts in commercial citrus. It's difficult to separate that out from the seasonal trends and what Mother Nature does in pushing the population up and down. It's kind of ongoing question, but it's a really gnarly bit of statistical analysis to try and pull those two things apart. Apart from anything else, it's difficult to get really good data on how much effort is actually being made in the commercial citrus. So it's difficult to, we don't know what that X factor is in order to separate it from the seasonal ups and downs.
And then another clarification on the study. Can you clarify if CLAS testing has only been done on adult ACP, or is this adult and nymph ACP CLAS results?
Everything I've said so far is adults only. And Judy is just about to start doing the nymph samples. So I should have data on what we're seeing in nymphs in 2 or 3 months' time, I hope. I'll let everybody know as soon as we've got information. We'll make sure you guys know as soon as we know what that data look like. I'm really hoping they all turn out to be zeros.
Great. So I have a couple of hands up in the audience.
Neil, if I was a grower and what you told us that psyllids are naturally going down in the winter, don't seem to increase in the spring too much. As a task force, we're treating in the winter and treating once in the summer and once in the fall. In your opinion, would it be more beneficial for a grower to take that winter treatment and apply it in the summer or fall with, would you get better efficacy? It doesn't appear to me that the winter treatment gets the best bang for your buck.
Yeah, this is where it'd be better to have an entomologist standing here than a plant pathologist. I know Beth had good reasons when she set the program up around that winter dormant period treatment, but I don't remember now what that was. I see Victoria's got her hand up.
Can I give you the mic so that people online can hear you?
She wanted that, we called it winter treatment, so that we could get those overwintering adults before they would start to build populations with the spring flush. So that was the reason behind the winter treatment, whether it's. And then the other part of it was that I think she was concerned about uptake for systemics in Ventura. So I don't know if she was thinking that was the best time for uptake. Broad spectrum in the winter, and then you're doing are you doing the systemic in the summer?
I think it's a question worth asking. I really do, especially when margins are tight and you know, you don't have that many opportunities to necessarily be in there and do something anyway with wind and other factors. So okay, I'll stick my neck out and say I don't think you'd blow everything up by trying it for a year and see what you think.
Yeah, my suggestion would be, you know, we've got more data now, right? Than when
Right.
Beth set this up.
Right.
Beth has retired, but I bet we could, you know,
She would answer the phone. I
send her
think.
some data and say, hey, take a look at this. And should we be changing our tactics in Ventura based on this data?
Yeah, absolutely. I think it's a really great question and definitely something to look at.
All right.
I know.
It's great to hear about the alyssum. It's cheap seed. It's like $20 a pound, and you don't need much. It comes up quickly from seed. It easily reseeds, and then you just scrape the ground and you get rid of it easily. But the Jenna experiments in Germany, looking at different mixtures of cover crop plants, found that at 8 different species growing together, that they would support each other, you get higher rate of carbon sequestration and greater resilience in stresses, like drought, flood, that sort of thing.
Mhm.
And so, yeah, listen's great, but look at mixtures of at least 8, maybe a dozen different species. And one of the things we've been playing around with is looking at, could we get a mixture that's like 60-70% California natives, so that they'd be even more resilient, plus be host for the indigenous insects, that would be using them as a floral resource. So like there's Agrostis palens, a low growing grass that you can trim like a putting green lawn. And then deerweed, which is a native legume, a low growing, and there's some forms of it that are, just 5 or 6 inches tall, similar to the alyssum. So yeah, building habitat, build it and they will come. Remember the
Yeah.
movie?
No, sure. If you're going to take the step of actually deliberately putting plants in there to encourage hoverflies, you might as well think about some other benefits you might get from doing it as well. Yeah, alyssum, I mention it because it's the one I know, but yeah, I mean, by all means, have a think about other stuff that you could do at the same time.
Is there anything you could do with the planting of the alyssum to help protect it from the spraying, i.e. protect the hoverfly? Could you plant it under the trees or I guess, yeah. Is there any way to plant the alyssum to help protect the hoverfly?
So I know Mark's group have got some experiments where they're actually looking at putting the alyssum in the tree rows between the trees, so that it gets some benefit from the irrigation lines that are there. Growing anything in the summer here, water is going to be the issue, right? So you can ask Mark. You can ask Mark to check in. Right. Yeah. No. I mean, yes. If you're going to encourage natural enemies, then you have to think about how to combine their presence with pesticides. If you also use pesticides, you do. Yeah. It takes some thought. I don't know. You'd have to ask Mark Hoddle. I'm guessing that will have been thought about, though.
Do we have any more audience questions? I'm going to check the chat really fast, but I think we got through all of those. Yeah, so with that, I want to thank Neil McRoberts. He's a good friend of our task force.